Example 2.4. Four charges are arranged at the corners of the square ABCD. Find the work required to put together in this arrangement. Okay. First step, what is the formula for a potential energy? That is work required to assemble the charge. That is nothing but total energy that is given by sigma K Qi Qg by R. That is same as potential energy. First, we'll see the product of charges A and B. Charge is plus Q and minus Q. Product becomes minus Q square. Now between B and C, minus Q and plus Q, that is also minus Q square. Between C and D, that is also minus Q square. Between D and A, that is also minus Q square. So energy due to AB, BC, CD and DA. So total 4 terms. These all 4 terms are equal. Therefore, energy due to side is given by 4 into minus KQ square divided by D. That is minus 4KQ square by D. Then now, 2 more terms left. That is energy due to diagonal. Energy due to AC as well as energy due to BD. Energy due to AC. So, product is Q and Q square. Here also, product of charges is minus Q, minus into minus plus Q square. What is the distance of AC? That is, according to Pythagoras theorem, D square plus D square equal to AC square. That is equal to 2D square. AC is equal to square root 2 into D. Okay. So AC product of charges is Q square. VD also Q square. Once again, these 2 terms becomes equal. Therefore, energy due to diagonal is given by 2 into KQ square divided by root 2 into D. 2 times KQ square. Separation is root 2D. If you simplify, this root 2 will get cancelled. It will come root 2 K D Q square divided by D. Now we'll go for the last step. What is the total energy? Total energy means you have to add energy due to sides plus energy due to diagonal. That is minus KQ square divided by D plus root 2 KQ square divided by D. KQ square by D is common. If you take out root 2 minus 4, this is the total energy. Now we'll go for the second part of the question. A charge Q naught is brought to the center E of the square. The 4 charges being held fixed at the corners. How much extra work is needed to do this? We are bringing the charge Q naught under this condition. How much extra work is required to be done? Okay. Work done formula, charge into potential. What charge you are bringing to the center? Q naught. What is the potential at that point? That we already calculated, right? So, work done equal to charge into potential at that point. How to find out the potential? Potential, first we will find out full diagonal root 2D, half diagonal is D by root 2. Therefore, now we'll go for potential. Potential at A due to the charge plus Q. 1 by 4 pi epsilon naught KQ by R. KQ by R. K is 1 by 4 pi epsilon naught. That is Q by R. R value is half of the diagonal. Root 2 KQ by D. Due to B, where B negative charge is there, minus root 2 KQ by D. At C, positive charge is there. At D, minus negative charge is there. Total potential, if you add all this is a scalar quantity, right? Just you have to add VA plus VB plus VC plus VD equal to 0. Now, total potential is 0. Therefore, work done equal to 0. The total work required to bring the charge Q naught at the center equal to 0.